Hello friends, today we will see the multiplication of vector by a scalar. So let lambda be any scalar and a bar be any vector. Then lambda a bar is called product of a vector by a scalar. So lambda a bar is also a collinear vector to a bar. Its direction depends on lambda value. If lambda greater than 0, then its direction is the same as the a bar. And if lambda less than 0 means negative value, then its direction is the opposite to a bar. And so lambda a bar represents the lambda product of a vector by a scalar, and its magnitude will be given by magnitude lambda into a bar. Magnitude a bar means the lambda a bar magnitude will be magnitude lambda times of the magnitude a bar. Now lambda equals to, we take minus 1, then magnitude a bar equals to, then product will be minus a bar, and so it will represent minus a bar. Lambda a bar equals to minus a bar, and so minus a bar is called the negative vector of a bar, which will give a bar plus minus a bar equals to 0 bar. Now if lambda bar equals to 1 upon magnitude a bar we take, then we will have magnitude lambda a bar equals to 1 by a bar into magnitude a bar, which will represent a, and so we can say that unit vector of lambda a bar will be given by 1 by magnitude a bar into vector a bar, where magnitude a bar is not equals to 0. Now next we will see the component of the vector. So we have the three directions, 3 axis, x axis, y axis and z axis. On x axis point A represents 1 0 0, B represents 0 1 0 and C represents 0 0 1, and O is any vector. O is initial point 0 0 0. Then the magnitude of OA equals to 1, magnitude of OB will be 1 and magnitude of OC will be 1, and so we can say that OA, OB and OC are unit vectors along the OX axis, OY axis and OZ axis. And so we can say that when on OX axis OA is one unit, and so OA is the unit vector. On OY axis OB is the one unit, so OB is the unit vector on Y axis, and on OZ axis OC is the one unit, so it is unit vector. Then so OA can be represented as I caret on the x-axis unit vector. On the y-axis unit vector will be represented as j caret, and on the z-axis unit vector will be represented as k caret, respectively. Now let P, X, Y, Z be any point. Then from the P we draw the P1 foot of the perpendicular. Then it is in XY plane, and so P1 coordinate will be XY0. And so P1P is parallel to OZ axis. As it is parallel to OZ axis, its unit vector along with IZK we take. Then P1P is equals to, it is parallel to OZ axis, so equals to O. If here point R is there, then we can take that OR equals to ZK caret. P1P direction axis. Now here we take O and here we take S. Then Q and here O. Then OP1 vector we will have here OQPS is a parallelogram. Now this is XI X unit and this is Y unit. Then X bar magnitude and Y bar magnitude. So by below a parallelogram, OP1 vector we will have equals to OS equals to YJ caret, and OQ we will have XI caret. So we can write OP1 equals to, so OQ XI caret and OS we have YJ caret. So OP1 equals to, we can write by parallelogram law X bar plus Y bar, and if we draw the OP vector, then here again triangle law we can apply. Then OP vector will be OP1 plus PP1. And so OP1 X bar plus Y bar or XI caret plus YJ caret, and PP1 is ZK caret. And so components of OP vector form is given by XI caret plus YZ caret plus ZK caret. And so this represents the vector form of any point P, X, Y, Z. It is also known as the component form, and Xi caret, Yj caret and Zk caret are the vector component of the P, X, Y, Z. Its magnitude will be given by OP vectors will be given by under root x square plus y square plus z square. Now A bar is any vector A1 I cap, A2 j cap plus A3 k cap, and B bar is any vector B1 I cap, B2 j cap and B3 k cap. Then A bar plus B bar will be given by A1 plus B1 I cap plus A2 plus B2 j cap plus A3 plus B3 k cap. A bar minus B bar will be given by A1 minus B1 I cap, A2 minus B2 j cap, A3 minus B3 k cap. Also A bar equals to B bar if and only if A1 equals to A2, B1 equals to B2 and C1 equals to C2. Sorry, A1 equals to B1, A2 equals to B2 and A3 equals to B3. If we take a multiplication with lambda a bar, then it will be lambda a1 I cap plus lambda a2 b j cap plus lambda a3 k cap. Also with the scalar we multiply, means k a bar plus k m a bar we take, then we can write k plus m a bar. K into m a bar also we can write km into a bar, and k into a bar plus b bar we can write k a bar plus kb bar. Now let a bar and b bar are two vectors such that they are collinear. A bar and b bar are collinear vector. Then a bar equals to, we take component from a1 I cap, a2 j cap, a3 k cap, and b bar equals to, we take b1 I cap plus b2 j cap plus b3 k cap. But they are collinear, so we can write b bar equals to, there will be a lambda a bar format, and so we can write b1 I cap plus b2 j cap plus b3 k cap equals to lambda a1 I cap plus lambda a2 j cap plus lambda a3 k cap. So we know that two vectors are equal if and only b1 equals to lambda a1, b2 equals to lambda a2, b3 equals to lambda a3, and so we can write b1 by a1 equals to b2 by a2 equals to b3 by a3 equals to lambda, and so we can say that two vectors are collinear if their component vectors ratio is the constant, and so we can say that if b1 by a1 equals to b2 by a2 equals to b3 by a3 equals to some constant, then a bar and b bar are collinear vector. Now in vector a bar equals to a1 I cap plus a2 j cap plus a3 k cap, a1, a2, a3 are also known as direction ratios of a bar. Also LMN are direction cosines of any vector a bar, then Li caret plus Mj caret plus Nk caret equals to cos alpha I caret cos beta j caret plus cos gamma k caret represents the unit vector in the direction of the vector, where alpha, beta, gamma are the angles being made by the vector with the axis